Yo, that was a loss of viewers, that's for sure. My goodness. You guys, sorry about that. Had a bit of a technical difficulty there. Sorry. I don't know how many people actually now. Isha. I was cooking at the highest level. That's funny. Guys, I'm sorry about that. Yeah, there's a bit of a situation that I had to attend to, and it needed me personally. So sorry about that. I know we were cooking nicely, but the cooking ended midway. It was like I don't know. I don't know if it was a stir fry or what, but I didn't intend to make you guys cry as I was cooking my stir fry. But I hope you guys, yeah, man. I guess the three-prong strategy that I was talking about is to simplify, factorize identity. Simplify, factorize identity. So I'm just gonna sort of like re-look at this question again. Cos of a negative angle times tan of 180 minus x, brackets sine of negative x plus cos of 180 plus x over 360 minus x. You want to screenshot the entire page. Okay, I'm sorry, kind of like dingy. I'm trying so hard to kind of focus it on in, but yeah, guys, don't worry, one day is one day. I'll better resourced, better machinery, better doors. One day is one day. For now, it is what it is. It is the situation as it is. My only cry is that I lost so many people in the process of of actually doing what I was doing, right? Which is kind of sucky. Yeah. So what I was saying here is that whenever you guys are doing simplification or identity type problems, this is basically your three strategy approach. You have to first look at simplification, all right? And I think, honestly speaking, what one needs to do is you need to have BEDMAS or BODMAS in your mind. That's like at the top of the ring of your approach. Because with BODMAS, right, you know, if there are brackets, that is your priority starting point. Exponents, division, multiplication. Now, multiplication and division may be of terms or whatever. Then addition and subtraction, you know, hence we are talking about like terms, addition and subtraction of fractions, multiplication and division of those fractions. That's all under simplification. All the rules that you've ever learned where simplification is concerned, these need to be vibrant and clear for you. BEDMAS, BODMAS if you want. Like terms, addition, subtraction of like terms, fractions where they are concerned. Function values like reduction, reducing function values, negative angles, angles greater than 360. All of the tools now need to be on hand. You need to be able to choose the right tool at the right time for the appropriate situation, if you know what I mean. Then being able to distribute, multiply out, apply the distributive law where the need arises. So these are things under simplification. And if there are things under simplification that can be done, then you ought to do them as your first ring of strategy and approach. When you are fresh out of these particular things, then you need to move on to your next ring, your second ring of strategies, which is to factorize. Okay, now factorization encompasses all different types of factorization. You need to be able to recognize highest common factor, recognize difference of two squares, recognize trinomial factorization, recognize grouping factorization, where trig is concerned. When you are done and complete with that strategy, you need to check back if there's any other simplification that can still be applied. And if there isn't, check again factorization. Okay, all right. Or if there is simplification, you do it. All right, because after factorizing, you must check back with simplification again and do it if there is. Then check factorization again. If there's none of the above, then you must check identity. You see? Yeah. And I guess this is the thing when you are doing these problems. You need to be constantly jumping back and forth between simplification, factorization, identity in this order. Once you are done with this one, you move to this one. Once you are done with this one, you move back to the first one. Once there is something that you identify here, you do it, then you move on to factorization. If there's no factorization and there's no simplification, then you jump onto identity. And that usually helps a lot. Guys, it helps a lot to jump back and forth between these three strategies. Okay, so for instance, here in this problem, if I'm thinking about board mass, I'm thinking of like there's a multiplication of two trig ratios, then there's a bracket, and encompassed in that bracket are two things that are added together. So this is obviously something that I can see, but in order to be able to add what's here, I need to first simplify the function values. There's no addition and subtraction of like terms. There's no multiplication and division of fractions or anything of that sort. So I need to evaluate my function values, apply reduction, negative angles greater than 360. Now, if I have forgotten what needs to be done with angles greater than 360, that needs to come back. If I've forgotten what needs to be done for negative angles, that needs to come back. So there's that sort of like interplay and exchange that I need to participate in. So hence I said negative angles, look at me apply. I add 360 to negative angles. 360 minus x. Tan 180 minus x. Okay, it's a function value. It's ready to be reduced. I will reduce it. Negative angle, I add 360. Okay, and then that basically makes a function value. I now have a function value, a function value, a function value. It needs to be reduced. I will be reducing it. Cos squared 180 plus x. Right, guys, I know that obviously I'm going to be taking out the square, evaluating the function value, and then I will apply the square later on. Sine of 360 minus x, I will be evaluating that function value, reducing it. So there we are. Cos 360 minus x, my first mark, cos x. Okay, because 360 minus is in the fourth quadrant, cos is positive there. 180 minus x, second quadrant, tan is negative there, negative tan x, second mark. 360 minus x, cos sine is negative in the fourth quadrant, negative sine x. Cos 180 plus x, obviously whatever I get which is negative will eventually, when I apply the square, it will become positive cos squared x. Here in the denominator, guys, sine of 360 minus x gives me, obviously 360 minus in the fourth quadrant, sine is negative there, so I have a negative sine x. When I apply the square to the negative at the top, it gives me cos squared x, which is positive. But then this negative sine x times this positive x, remember two signs next to each other, this one has already been sorted because the square is applied to the negative sign, it becomes positive. But this negative sign in the denominator gets multiplied with this positive sign, it makes this positive sign negative. Okay, those are marks, guys. Those are marks that you get because it's important, right? Now what you have inside the bracket is a negative sine x over 1 minus cos squared x over sine x. Okay, and I want to teach you guys a little trick when it comes to addition of two fractions. Don't waste your time, guys, and try and get LCDs and all of those things if you have two fractions. Here's a trick. You multiply this guy with this one. You multiply this guy with this one. and then you multiply these two together. So basically what I would have as my answer is AD plus CB over BD. That would be my answer. Okay, so check this out. I'm going to do the same thing with this. Okay, are you ready? Okay, so obviously what I did with the negative tan x, if you saw, I said negative tan x, I changed that to the identity. Okay, because there's no factorization, right? No factorization. For these two things that are multiplied together, there's simplification has been done. I have no further simplification. There's no factorization. So now I have tan x, which is an identity. I change it to the identity. That's another mark. And then I'm sure you can see simplification will happen between my multiplication of these two. I'll come back to it. In fact, let's do it. Cos x divided by cos x. Those two will cancel. I'm going to be left outside with negative sin x. Let's go inside now. Two fractions. I need to add, subtract them. So sin x times negative sin x gives me negative sin squared x. Remember I said you multiply these two, you multiply those two. 1 times negative cos squared x gives me negative cos squared x. And then 1 times sin x gives me sin x. Okay, I just, from my identity that I use to simplify, inside the bracket, because you deal with the bracket alone, brackets, BODMAS, brackets first. So I deal with the bracket alone. I add the two fractions. That's simplification. Okay. Now that I've added the two fractions, I go on to the next step of thinking, which is what? Which is I'm thinking now, after simplifying, I'm thinking of factorizing. Okay. I'm thinking of factorization because there's nothing else I can think of. I'm thinking of factorizing. I can see at the top there in the numerator I have a negative sign. So I'm going to take it out. And that's what it leaves me with. Can you guys see that? I hope you can. Okay, so I've just factorized. I took out the negative sign, leaves me with sin squared x plus cos squared x. Okay, so after factorizing, now I'm thinking, is there any other simplification that can be done inside the bracket? No. No. Is there then factorization I can do? No. I move on to the next ring. Identity. Oof, what is that, guys, in the brackets? What is that? Sin squared x plus cos squared x gives you what? Isn't that going to give me 1? Sin squared x plus cos squared x, that's the identity. It's equal to 1. Do you see that, guys? This thing of identities. Sin squared x plus cos squared x is equal to 1. I took out the negative 1, which is the highest common factor. Leaves me with sin squared x plus cos squared x. That is 1. 1 over sin x. Ooh, look at this. This, the bracket means multiply. So I'm going to multiply these two, because I'm left with a fraction, which is 1 over sin x, negative 1 over sin x, and negative sin x on the outside. So this sin x and this sin x, what happens? They cancel. And I'm left with what? Positive 1. Done. 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 Okay. So I don't know if there's anyone who has any questions. Yeah, it is easy marks, very easy marks. All right. But it is this thing of playing between simplify, factorize, identity. Simplify, factorize, identity. Simplify, factorize, identity. Yo, TTV, you're writing a test tomorrow. You need to learn grade 9 ratios. That's very true, hey. that's very true. I think a lot of the learners, when they do things with us as tutors on the platform, then they can see their future shine brighter. Yeah. But I think what's important here then is to take what you learn, the strategies that you learn, and then you try and apply them as you go along, you know. So once again, I'm just going to repeat it. Yeah. Cos of negative x times tan of 180 minus x into sine brackets sine of negative x plus cos squared into 180 plus x over sine of 360 minus x, close bracket. So if we look at the situation here, yes, simplify, factorize, identity, simplify, factorize, identity. You are jumping across, jumping. Yes, I am a teacher, TTV Kelvin. And you said you wanted to, you're writing a test on ratio. Yeah, ratios are simple for grade 9. Simplification of ratios, I'm sure you can do that. Simplification of ratios for grade 9. 2, you must know how to divide a certain quantity using a particular ratio. That's 2. Then 3, you need to know how to increase and decrease a ratio. Okay. Yeah. You can jump onto my YouTube channel as well. I have a playlist for the grade 9s. I did ratios, like I did simplification of ratios, and I did different scenarios of ratios. Okay. Yeah. Well, you are basically talking about that as well. Okay. Go to my bio. Yeah, there's a link on my bio. You can go on there. There's a grade 9 playlist that I have of the lessons I've done with on this particular platform. So as far as that is concerned, so I am still relatively new in this platform, guys. I'm not a fluent at all as of yet. It's just me kind of taking it one step at a time. So I've done much of the term 1 work so far for grade 9, for grade 10, for grade 11, and to some degree grade 12, but I have not gone to the furthest extent. But the first few topics for grade 9, for instance, I've done, like your ratio, rate, financial maths. So you can check out my playlist. Like I said, go to my playlist on my YouTube channel. Please subscribe. I'd appreciate the subscription. You can subscribe to my YouTube channel, and you can go to the grade 9 playlist and just watch what I've done so far. Okay. And the ratios, I've done them, increase, decrease, even with your direct and indirect proportion. You can check that out as well. Okay. No, Liabona, I haven't done 3D trig. Okay. I haven't done that. I'm going to identities after this problem. Just hang in tight. I'm going to identities, but I obviously simplification, because for identities, the same strategy applies. Simplification, factorize, identity. Simplification, factorize, identity. Identities are even easier because they give you the answer. Simplification, you don't know the answer. So you actually literally have to do things correctly as you go along. All right. So I tend to feel that simplification is more difficult than identities. If there's difficulty at all both in identities, which I don't think there is. Cos negative x times tan 180 minus x sine of negative x plus cos squared into 180 plus x over sine 360 minus x. So what we did here, we looked at this. You can see here there's a multiplication of two things. There's a bracket, which means multiply. So there's a relationship of multiplication of this, all of it, with that. Okay. But inside this bracket, we have addition. There's a ratio here. It's negative in nature, negative angle. And then there's this particular fraction, but it has function values. All right. So before we can even add these fractions, the sort of simplification that needs to happen for everything here is one of applying function values, because we don't have like terms, we don't have addition and subtraction, multiplication and division of fractions that actually will lead to something being simplified. So what we do have is function values and possible function values, which we can get if we apply our knowledge of negative angles. So negative angles, negative x, we add 360 to negative angles. That's what we did here. we're gonna evaluate this function value and reduce it soon. We add 360 to negative x. We took out the squared, so 180 plus x can be written as a function value. This is 360 minus x, sine of 360 minus x, okay? The next step, reducing 360 minus x gives us cos x, because 360 minus is in the fourth quadrant, cos is positive, 1 mark. Tan 180 minus x is in the second quadrant. In that quadrant, tan is negative, second mark. 360 minus x, fourth quadrant, sine is negative in that quadrant. Cos 180 plus x is negative cos x, but if I apply the squared, I get positive cos squared x. Okay, because the square applies applied to the negative sign makes it positive. In the denominator, sine of 360 minus x, sine is negative in that quadrant. Okay, and all of these evaluations, guys, we get marks, so don't take these evaluations reducing for granted. These are like marks, guys, quick fire marks. Then this negative sine x times this positive cos, this positive sine will give you a negative, all right? Then you have negative sine x over 1 minus cos squared x over sine x. So you have two fractions that you can subtract here, all right? Let's go to the outside. We have cos, we've got negative tan x. Since these two are multiplied together, all right, we can actually change the identity because there's no other simplification we can do here. There's no factorization you can do between these two, okay? But then you change this identity to negative sine x over cos x because this is the quotient identity, right? Then the addition of these two fractions. Remember when I say, what did I say about the addition of two fractions? You can simply multiply this denominator with this numerator. It gives you negative sine squared x because it's a negative times a positive. Then you multiply this 1 times the negative cos squared x gives you negative cos squared x. And then 1 times sine x gives you sine x. All right? Yeah. And then remember, these two, if you multiply together, the cos and the cos cancel, you get left with negative sine x. Now it's ready, this negative sine x, to get multiplied here, but we need to simplify what's inside. So we take out a negative sign because we can factorize. We take out the negative sign, we're left with sine squared x plus cos squared x. This is the identity, which gives you 1, but it's negative. Okay, and then over sine x, there it is. And this sine x and this sine x, they do what? They cancel each other. Negative times a negative gives you a positive, and obviously it's positive what? Positive 1. Okay, so yeah, that is dot 1. Okay, that is dot 1, which is a beautiful one. Okay, I don't know if there's any further questions with regards to that. Okay, if there aren't any further sweet questions, then I want to look at an identity here. You have cos theta into tan theta plus 1 over tan theta is equal to 1 over sine theta. That is funny. Physics, you're killing me. I'm guessing all of that so that the answer can be 1. Yeah, that is it pretty much. Okay, guys, let's look at this question. So if we look at this particular question, right, we have cos theta into tan theta plus 1 over tan theta. Okay, so cos theta into tan theta plus 1 over tan theta, close bracket, is equal to 1 over sine theta. And they are saying prove the identity. Okay. Oh, draw the quadrants for a visual. I thought you guys knew the quadrants, so I guess that's why I didn't bother to do that. CAST. Okay, so that's quadrant 1, that's first quadrant, that's second quadrant, that's third quadrant, that's fourth quadrant. So this is the 180 minus quadrant, this is the 180 plus, this is the 360 minus. Okay. That is funny, TTV. That's good. That's good. Well, I hope you now know. And that's very important. All of these things, they are very important. Okay. I definitely, every single time I do a video, that's why my videos, they are worth your time, because I definitely break down and give you some nuggets. And sometimes when those nuggets come and it hits in your head that, oh, this is what it means, then it actually facilitates you having a deeper understanding of something, and then it makes once you have understanding that accompanies your mathematical practice, your next level stuff, bro. That is cooking on another level. You are like Gordon Ramsay of maths, bro. Like on another level. It's like a Gordon Ramsay of maths, you know. Yeah. So anyways, yeah, guys, just remember as well, okay, that with these, okay, 360 minus and stuff, if you guys want to know the signs very quickly, I just want to repeat what I said earlier on. You can just take, see, nowadays you want to shortcut stuff, like, you know, people know the quadrants but they forget, don't they? So what you can do now is you can actually substitute in the place of x the number 1, okay, and then just 1, you know, or any other acute number if you want, any number that's between 0 and 90, and then you substitute. Look, so this is a positive value, so that means cos will be positive. Let's go to tan, 180 minus x. So instead of like you know, trying to evaluate these things, say tan 180 minus 1, okay, most you want to check, is it positive or negative? So tan 180 minus 1, look at this, look at the answer. It's a negative, you see? So that means it's a negative sign that we can put. Okay. Do you know what I mean? Yeah, and so it goes. You can basically substitute this one every time to just check what is the sign of each ratio. Okay, instead of like, yeah, because I know some of you are lazy to even, you know, remember. Some of you will even forget. All students take care, all students take chemistry. You forget those things. When push comes to shove, when you have shoved so much information in your heads, you forget all of these things. So the way to basically shortcut the process so that you know what the sign of the trig ratio is to just substitute 1 in the place of that theta or that x value, and then make sure you check what is the sign. The sign here is negative for tan 180 minus x. You can check for all the ratios, you will always know what the sign is, because that's the major thing, the sign, hey? The sign, okay? Anyways, that's just shortcut stuff. Okay, let's go back, prove the identity. Cos theta, tan theta plus 1 over tan theta is equal to 1 over sin theta. So like I said, what do? We simplify. This is cos theta, it's one thing on the outside. This is tan theta plus 1 over tan theta. So this cos theta is going to stay put for now until further notice. BODMAS says we look at the brackets because simplification turns us to the brackets. Tan theta plus 1 over tan theta, what is this? This is an addition of what? Of two beautiful fractions. Okay, so what we can do then, guys, is to just, I guess you could say, take tan theta. All right, we know most that we could simplify, factorization not there, identity. So let's just use the identity. Sin theta, cos theta is sin theta over cos theta plus this 1 over tan theta. Remember, 1 over tan theta is the inverse of tan. So if 1 over tan theta, this is 1 over sin theta over cos theta. Okay, but we're taking here the what? The left hand side. Okay, so we're taking the left hand side because we want to prove it will be the same as the right hand side. So we take the complicated side, which is the left hand side. We've just changed tan theta to sine theta over cos theta. Then 1 over tan theta, what did we do to 1 over tan theta? We wrote it as 1 over sine theta over cos theta. But if we rewrite the 1 over sine theta over cos theta, it's actually equal to cos theta over sine of theta. Hope that makes sense, guys. The cos theta is still outside. Do you see how that works? Okay, because if you want to understand this is like saying 1 divided by sine theta over cos theta. Does that make sense? Then what do you do to them? Divide, you change it to multiply. What happens to the second fraction? It becomes cos theta over sine theta. So that's why this is actually equal to cos theta over sine theta. Okay, this is like saying 1 divided by sine theta over cos theta. So here it is, 1 divided by sine theta over cos theta. I change the divide to multiply. What happens to the second fraction? It becomes cos theta over sine theta. It's like we tip and turn. Then what's 1 times cos theta over sine theta? It's cos theta over sine theta. So there it is, guys. There it is. Okay, I hope we're flowing together. So this is sine theta plus cos theta over, oh, sorry, my bad. What am I doing? Now I can add these fractions. Remember what I said when we adding fractions, when the denominators are not the same? So check what we do. We take this one, we multiply with that. Please go back to explaining how it changes when dividing. Okay. AR9, first and foremost, do you see this is 1 over tan theta? I hope you do. Tan theta is the identity sine theta over cos theta. So I've just changed tan theta to sine theta over cos theta. But what does it mean? It means 1 is divided by sine theta over cos theta. So here it is, 1 is divided by sine theta over cos theta. Because you are wondering, why did I move from this to that? The reason is because 1 divided by sine theta over cos theta, if you change the divide to multiply, when you were in grade 8 and 9, when you were dividing two fractions, like if you had 2 over 4 divided by 1 over 8, for instance, you would change the divide to multiply, and then the fraction, because you changed the divide to the inverse operation, you would invert the second fraction. The second fraction would tip and turn. 1 over 8 becomes 8 over 1. Then you would simplify. So we are doing the same thing here. 1 divided by sine theta over cos theta becomes 1 times cos theta over sine theta. Then the multiplication of 1 with cos theta over sine theta gives me cos theta over sine theta as a final answer. So hence, I am saying to you that this is actually equal to that. Remember as well that this is 1 over tan theta. This is the inverse of tan. So it stands to reason that if tan theta is sine theta over cos theta, what is the inverse of tan? It is cos theta over sine theta, right? If we were to shortcut the process. Okay, so I hope that makes sense now. Now let's focus on this inside of this bracket. Denominators are not the same. So what do? We apply our strategy, sine and sine. So it becomes sine squared theta. If we had same denominator, we would keep the denominators and add the numerator. Remember, in fractions, you see, we're going back to the rules of fractions, guys. Remember, when you did fractions in earlier grades, when you are adding two fractions and the denominators are the same, you keep the denominator, you add the numerator. So the answer becomes 2 over 3. The whole goal of adding and subtracting fractions is that we only add fractions if the denominators are the same. Then that allows us to keep the denominator and to add the numerators. So in the same vein, look at here, we don't have same denominators. So what do we need to do? We need to find the LCD. But now I said to you guys that for trigonometric fractions, if you have two fractions, the quick and easy way to add those fractions is to simply take the sine, this denominator multiplied with this numerator, it gives you sine squared theta. You take this denominator, you multiply with that numerator, it gives you cos squared theta. And then you multiply the two denominators, sine theta, cos theta. Okay, do you see that? Yes, guys. Liabona. I cannot overemphasize how important the basics are. All right. One of my learners at my school, actually, who was consistently getting level 3s and 4s in grade 9, he literally became like one of the top students in my school, grade 11. And he literally got 100% for term 1, term 2, term 3, aggregate of 100% for 3 consecutive terms. And when I asked him the question, like, what changed? Because he even wrote a baseline test in grade 10 when he was coming from grade 9, and he scored one of the lowest marks. He actually failed the baseline test, for lack of a better word. He failed the baseline test. He basically got the lowest marks in the grade. But then, funny thing is, come grade 10, beginning of the year, he picked up, and like during the course of the year, like he was performing like top of the class for maths. Then grade 11, he was top all the way, 100% for 3 consecutive terms. So when I asked him the question, term 1, I was like, dude, like, what happened to you? He's like, sir, the basics. I had to literally go back and make sure that all the basic things in grades that I had passed in grade 8 and in grade 9, the fundamental basics, I had to make sure I mastered them. That's why it's changed everything for me. And you can see that, like, the way he does things, he's clinical now. It's crazy. He's crazy, man. He does so amazing. So he's now in my grade 12 class, and yeah, I can only expect amazing things this year from the boy. He's phenomenal. And I love the fact that he actually understood the mission, that it's basics, man. Okay, so now look at this. So there it is, the fractions we've added. Okay, we've applied LCD. The LCD, even if we said what is the lowest common denominator, it obviously would be the product of cos theta and sine theta. Okay, I just want to sort of like accommodate those who would say LCD. Yes, it would be the product of cos theta and sine theta because they are unique, all right? And so the lowest common denominator is the product of the two. Then what you would do is, what would make cos theta be the same as cos theta sine theta is if you multiply the denominator by sine theta. But what you do at the bottom, you do at the top. Okay? So there it is, sine squared theta. Then what would you do here? You would multiply sine theta by cos theta to make it like the LCD. But what you do at the bottom, you do at the top. That's why you get cos squared theta. Okay? And then there it is, guys. Sine squared theta plus cos squared theta. What do you have inside the bracket? Sine squared theta plus cos squared theta. Exactly, lovely. 1 over sine theta cos theta. The identity. No simplification, no factorization, identity. You see, guy, SFI, simplification, factorization, identity. You know, no simplification, no factorization. So we look at identity. There it is. Okay, we are done with the identity. We go back to simplification. Is there simplification that can be done? Yes. Cos theta times this 1 over sine theta cos theta. The cos theta in the numerator, the cos theta in the denominator, they cancel. You are left with 1 over sine theta. But that's what we wanted to prove, right? That's what we wanted to prove. This is the right hand side. So the left hand side is equal to the right hand side. Okay. And this addition of fractions, guys, is such a recurring theme. Like the addition of fractions with identities, it's so recurring. Like I was looking at the 2018 paper, you know, maths paper, grade 11, and there it was, addition of fractions. 2013 example, there it was. And 2014, addition of fractions, there it was. It's like addition of fractions, recurring, there it was. And guys, the SFI strategy works. It works. It works. And that's why all of you then need to be so good. Even in grade 12. Even in grade 12. Even in grade 12, guys. Even in grade 12. Okay. Guys, I am going... Okay, I just want to finish off what I... Yeah. No, don't at all. Before this live, I put off trig functions, but now I decided to stay. And hey, it's simple. It is simple, man. It's simple. Too much. Okay. Sorry. Just a question that may come with that question that I've just done. Let me just check this out. The question says, give the values for which the identity is undefined. The values for which the identity is undefined. Okay. So remember that the identities for which, okay. So I am actually going to look at, remember when they say for which the identity is undefined, you need to look at the denominator, because undefined has to do with, you can't have denominators being equal to 0, right? Because if you have a 0 denominator, we know that a particular equation will be undefined if the denominator is 0. So what you then do is you take the particular denominator for that particular identity, you equate it to 0, and then you solve for it. Okay. And if they say find the general solution, you find the general solution. If they say find the specific value of x within a certain interval, then you find that specific value of x within the interval. Okay. I just want to look at one question where they say find the general solution, and then I'll be happy to take any of your questions, guys. No. Liabona, two things. 6 divided by 0 is undefined. Okay. Square root of a negative number is non-real, not undefined. Both of these in your calculator say maths error, but they don't mean the same thing. Okay, please, they don't mean the same thing. The maths error for a negative number underneath a even square root means non-real. This is a non-real. Division by 0 is undefined. These mean two different things. They don't mean the same thing. Okay? Yeah, though your calculator says maths error. Okay? Please. Because sometimes you guys get questions. Okay? You guys sometimes get questions where they say for which values of x is a certain expression non-real. Now, non-real does not mean the same thing as undefined. Okay, so any negative number under a even square root is non-real, but for undefined, that means 0 denominator. We try and avoid 0 denominator. Okay, yeah. So undefined is that. Division by 0 is undefined, whereas a negative number under a square root, non-real. Okay. Please, or under a even root, that's non-real. So they don't mean the same thing. Okay, here we are. Sure, guys, sure. 6 minus 10 cos x is equal to 3 sin squared x. They want us to find the general solution. Okay, the general solution. Yeah, there we go. Look at that. People are busting out some busting out some also. No, can't be irrational. Irrational numbers, remember, Kelvin, an irrational number is a number Remember, there's a rational number. Rational numbers are numbers that can be written as a fraction. In other words, where a or the numerator is an integer. Integers are positive and negative whole numbers, and b is also a integer. That's a rational number, and b cannot be 0. Okay, yeah, meaning the denominator cannot be 0. That's rational. Irrational is the opposite. Okay, irrational numbers are the opposite of rational numbers. Or also, rational numbers can be either terminating, meaning in the decimal they can be terminating. Sorry guys, I just want to answer this question because they're important questions. Terminating decimals means after the comma the numbers, they stop. You know, like Terminator, he kills, eliminates, annihilates life. Terminator. To terminate something means to stop it, 0.75. Or it can be recurring, 0.7. A repetition of a number after the comma without stopping. That's recurring. So those are rational numbers. That's the family of rational numbers. But irrational numbers are non-terminating and non-recurring. So in other words, like the square root of 2, you can see if you put in the square root of 2 in your calculator, the decimal does this very interesting thing. Because the number inside the square root is not a perfect square, when you see the decimal number, you can see that there's no repetition of numbers. It just goes on forever and ever. But there's no repetition. So it's non-recurring, meaning there's no repetition, and non-terminating, meaning it doesn't stop. It just goes on forever. So those are irrational numbers. So you can't say the square root of -5 is irrational. Why? Because it's a non-real number. Non-real. Okay? And non-real means non-real. Okay? And your grade 11s will tell you when they do nature of roots, for instance, they know that, they know a lot about non-real and non-real roots. So those are important concepts. Once you understand those concepts in earlier grades, when you come up to later grades, you will find ease in these things. There will be no problems. But there will be problems when you don't understand these things. Maths is easy, guys. Maths builds from it's like building blocks. Maths, that's how maths is. You lay one foundation, as good as your previous foundation is from the previous year. That's how good your maths will be come next time, because you will borrow strength from what you actually mastered from the previous grade, and it will make life easy in the current one. So anyways, let's look at this general solution. 6 minus 10 cos x is equal to 3 sine squared x. Now this 3 sine squared x gives us an indication that it seems like we will be dealing with a question that basically will require factorization. Okay, and this is the thing, a question that will require factorization, because we have 3 sine squared x, right? We have 10 cos x. Okay, so let me just rearrange this a bit. 3 sine squared x, then take the minus 10 cos x over, plus 10 cos x, then the 6, take it over, minus 6 is equal to 0. Okay, then since I have a cos x term, which would suggest this would probably be my middle term, let's change sine squared x to 1 minus cos squared x. It seems like that would be the favorable choice to make. Okay, maybe someone would be asking, why didn't you change 6 times 1, for instance, and just change it to 6 times 1, which would basically mean you change it to sine squared x plus cos squared x. The thing is, if I'm going to introduce sine squared x plus cos squared x to sine squared x, that's just going to make my life more complicated. But I want to simplify my life, so I can see that this is a potential trinomial, but rather than make things different, let's try and change the sine squared x using my identity so that I can actually complement the cos x, which is a potential middle term for a trinomial. Do you see that? Then I distribute the 3 minus 3 cos squared x. No, 0 is not an imaginary number, guys. 0 is a neutral number. It's a whole number. It is a rational number. Okay, please, guys, 0 is not an imaginary number. Okay, the square root of -5 is an imaginary number. Okay, non-real numbers are called imaginary numbers. Okay, yes, TTV Kelvin. Okay, seems like you are feeling the fire there. -3 cos squared x plus 10x. 3 minus 6 gives me -3. Okay, all right, and then let's do this for a moment there. Let's multiply out by a negative. What's this? 10 cos x minus 3. So let's do this. 3 cos squared x minus 10 cos x plus 3 is equal to 0. All right, then seems like factorization could be possible here. 3 cos x times another cos of x minus 3 minus 1 is equal to 0. 7 is a natural number. -7 is a natural number. -7 is not a natural number. -7 is only an integer. Okay, yeah, integers are positive whole numbers, meaning they start from 0, they increase by 1 up until infinity. Okay, yeah, and that's pretty much about it. Some Gelisi Wendlini 6, you don't understand this step of factorization, guys. Now this you guys, yes, the quadratic formula can definitely work. Yes, the quadratic formula can definitely work. So for people that feel like they struggle with this, you can use the quadratic formula. If like solving for a quadratic trinomial where the coefficient of the x squared term is not 1 is difficult for you, you can definitely use the quadratic formula. So what would you have to do? You would let, maybe you would let cos x be x, and then you'd have, or let cos x be some other variable or something like that. Okay, yeah, then you can use the quadratic formula. You can do that, but you would have to let cos x be x or something. Okay, and it's very important. If you're going to let cos x be x, then it means you are going to say 3x squared minus 10x plus 3 is equal to 0. Then you use the quadratic formula. But then you'd have to not forget to basically equate cos x to that value of x that you got, so that you can be able to then solve for the required thing. Are you with me? It is life, guys. Factorizing, guys. I teach I've taught grade 8s in my school. I taught grade 8s last year, and I'm teaching grade 9s this year. And I have 4 classes in grade 9. And that grade 9 class will know everything that they need to know, because I'm teaching grade 12 as well this year. So if my grade 9s, when I teach them stuff, I'm making sure that I emphasize certain things, because I know where we're going, right? Factorization is life, guys. Factorization is insanely life. Okay, yeah. So I'm just saying, for those that feel let's say you feel like you don't this factorization thing for you is not working out, okay, then you can let cos x be equal to x, for instance, right? And then this equation will become 3x squared minus 10x plus 3, which is equal to 0. Then you're going to use the quadratic formula, right? X is equal to minus b plus minus b squared minus 4ac over 2a. Do you see what we just done here? And then you go ahead and then you can do that. Okay, yeah, you would obviously substitute like that. Minus 10 4ac over 2 into 3. You'll get your 2x values most. X is equal to what? 3, or x is equal to 1 over 3. But Kengoku, what you are, yes, it is haunting you guys. It's haunting you because I'm sure you guys never took it in serious. But you see now at least you have the quadratic formula, guys. Okay, please don't despair. All right, don't despair. Okay, don't despair. So then you can actually then look, remember you wanted to, you said cos x is equal to x. So you got now your x values. After you got it, you go and write cos x is equal to 3 or cos x is equal to 1 over 3. Then you can go about and find your general solution. There you go. Obviously this one, there'll be no solution here. Okay, but here there'll be a solution. Oh man, here there'll be a solution, guys. Cos x is equal to 1 over 3. Okay, but let me go back to my factorization, guys. My factorization is 100% correct, by the way. I've checked it. 3 cos x times cos x gives me 3 cos squared x. Minus 1 times negative 3 gives me positive 3. The multiplication of this gives me negative cos x. This one gives me negative 9 cos x, the addition of which gives me negative 10 cos x. Okay, so it works out nicely, and very, very nicely it does. Okay, so let's go. You guys are killing me in the comment section. I think TTV Kelvin is just killing me with the comments. Cos x is equal to 1 over 3, or cos x is equal to 3. Okay, the reason why I say there's no solution here is because I know the cos graph does not pass through 3. Like the y value, it's impossible to get a y value for your mother cos graph that is 3. So that's why I dismiss this one immediately. I mean, you can even go ahead and take the arc cos of 3, and you'll see it won't give you nothing. So this is the only viable solution where I can get a general solution. So I'm going to do this. X is equal to, then I use the reference angle, which is equal to the inverse of cos of 1 over 3. This is what we do, guys. We find the reference angle. Okay. We ask ourselves, where is cos positive? Cos is positive in the first and the fourth quadrant. Then the reference angle is basically the one that we are going to use for each quadrant. Quadrant 1, quadrant 4. So we're going to say x is equal to the reference angle in quadrant 1 plus k 360, where k is an element of integers. And then for quadrant 4, x is equal to 360 minus the ref angle plus k 360, where k is an element of integers. Okay. Uliabona is like, yo. Liabona, what's happening? Kelvin, Kelvin, this grade 9 learner, I think is really lighting up the comment section, but I don't know if it's a positive thing. No, it's not important. I was just it's not important to write the reference angle. I just wanted to show you guys that the reference angle is basically what you put in here. So this is for teaching purposes. Some of the things that I'm doing here is for teaching purposes. I'm just writing these things so that you can see. All right, so this reference angle part is just for you to realize that you are writing whatever angle you get, which is arc cos of 1 over 3. What is arc cos of 1 over 3, guys? What is the the value so I can write it down. Yeah, that's RA. Yeah, that's referencing. Kaloko, what did I say? Okay, let's just do this. Remember, what you do here, 70.528, okay? Thank you, Sban. Then obviously I'm going to round it off. So it's going to be x is equal to 70.53. Thank you. Because they have to round it off to 2 decimal places. Then for the fourth quadrant, let me just do it here because I've just not too much space there. X is equal to 360 minus 70.528 plus k 360 degrees, where k is an element of integers. Just tell me, what's the answer there? Yeah, that's fine as well, baby girl. You can say 360k. Remember, guys, multiplication is commutative. In other words, k times 360 is the same thing as 360 times k. So it doesn't matter. It really doesn't matter, baby girl. It's so weird calling that person baby girl because I'm like... You're kidding, Miss Ray. You're doing this in an engineering class. That is so cool. No, that's fine. That's fine, baby girl. That's fine. It's okay. I just thank you so much, non-Cindy. So plus k 360, where k is an element of amazing integers. There it is, guys. There it is. Okay, there it is. So those are our general solutions. Okay, these are our general solutions. So back to the top, just for those who probably missed it a bit there. Or is it 477? Wait a minute. No, I don't agree. You don't agree with what? Guys, what's the actual solution then? The rounded off to 2 decimal places. 360 minus, say 360 minus the original value. Okay, the original value. Yes, I'll be putting this on my YouTube. Guys, remember K360, okay? Remember that this value, 477.477, so it's 48 then, if you round it off to 2 decimal places. Because if it's 77, then it's 48. If it's really 477, if 360 minus this cos of this inverse of 1 over 3, then if it's 477, then it's 48. Okay, it's only 47. Okay, that's fine. All right, let me recap then. Okay, that's fine. All right, Miss Ray, where did you go to? Like, I mean, did you finish matric last year? Like, because if you're saying that you're doing this in an engineering class, how does that work? Okay, 6 minus, I'll explain, Sam, why we say K360. 6 minus 10 cos x is equal to 3 sine squared x. Guys, they are asking us to determine the general solution. Now, this is the thing. This solution is not a specific solution, right? In grade 10, when you guys did solve for theta or solve for x, okay, you were always given the interval 0 to 90 degrees by which they would say they wanted your solution for x. In grade 10, you guys were restricted to working in the first quadrant. So you didn't write a general solution in grade 10. In grade 10, you guys solved for an unknown and you were given the interval 0 to 90 degrees as the only working interval. So whatever you solved at the end, you were able to get an answer, and that specific answer was an answer that basically was in the first quadrant, and that was it. In grade 11, what we do is we open up your world and we start looking for answers not only for the first, second, third, and fourth quadrant for your interval between 0 and 360, but we start looking for a general solution. Which general solution can help me and you find answers in other intervals? I could be asking for answers in the negative interval between negative 360 and negative 540. So through the general solution, you are able to find specific values of the unknown in other quadrants, okay? And what K360 simply stands for is, if you think about it, if you take this K and you multiply it by 1, that simply means you are talking about your first revolution, 0 to 360 degrees, okay? Then you can times by 2, it means we move over to the next interval, which is 360 to 720. You times by 3, we move on to the next interval of a revolution. So basically, we are basically looking at multiple revolutions. So this K simply stands for an integer, right? And because we know that because we know that 360 is the period of the sine and cos graph, our sine and cos graph completes a full cycle in 360 degrees. It means the more we continue in the positive direction, we have a second cycle, a third cycle, a fourth cycle, a fifth cycle. And obviously, as we go on and on and on to more and more cycles, it means that we are increasing more and more in the positive direction. So this allows us to basically have a general solution by which we can be able to find other values or other angles in other quadrants, whether it be further on or it could be in the negative direction where we have negative angles. All right, so that's why I'm saying that in grade 10 you guys were restricted, very restricted, okay? But then in grade 11 we open up your world. So there it is, 6 minus 10 cos x. Yes, Busisiwe, 180 is only for tan, because the period, one complete cycle of the tan graph can be completed in 180 degrees. And that is the critical thing there, all right? One complete cycle of the tan graph is completed in 180 degrees, not 360 degrees. That is why the period of the tan graph is 180 degrees, because a complete cycle of the tan graph is completed in 180 degrees, not 360, okay? Yeah, because that is what period is. Period is basically referring to how many degrees does it take to complete a full cycle of that particular graph, okay? Okay, does that make sense? I hope it makes sense. And rate me guy, I hope if you are saying you got a completely different answer for the cos inverse of 1 over 3, then maybe you need to check if your calculator, is your calculator in degrees or is your calculator in radians, okay? Yeah, hopefully that is also something you need to check, okay? Okay, let's go. So let me just go over this just for the purpose of what someone asked. You're so lost, lovely, with what? What are you lost with? No problem, Nonsense. What are you lost with, lovely? You said you're so lost. What are you lost? Okay, 6 minus 10 cos x is equal to 3 sine squared x, okay? Yes, I'm repeating the example. 6 minus 10 cos x is equal to 3 sine squared x. All right. Then this here, to me suggests that we are somehow going to be having a quadratic trinomial. Why do I say that, guys? It's because I see this 3 sine squared x and I see this 10 cos x. And remember, this here is an x term, but this one is a square term, and this is a constant term. So already in my head, my juices are flowing, and they're saying, okay, I have a cos x term. I need a cos squared x term. All right. But how am I going to get it? All right. So if I look at this 3 sine squared x, if I rewrite this into standard form where this is positive, I take the minus 10 cos x over, it becomes plus 10 cos x. I take the 6 over, it becomes negative 6. Yes, Busisiwe, that's definitely what I'm talking about. The standard form, ax squared plus bx plus c. So I have that in standard form. But this is sine, this is cos. So if the cos x term is the middle term, I need to change this to have cos. So I look at my identity. You remember, most the identity can be written, the subject of the formula sine squared x can be written as 1 minus cos squared x. Okay. Sine squared x can be written as 1 minus cos squared x. Okay. So I can replace sine squared x with 1 minus cos squared x, the identity. The 3 is still outside. All right. So I definitely put brackets there, and then I replace sine squared x with 1 minus cos squared x, the expression of the identity. Okay. Plus the 10 cos x, there it is. Minus 6, there it is. Okay. Equal to 0. I'll be doing the grade 12 work tomorrow morning at 5, my good friend. Okay. Then you distribute the 3. 3 times 1 is 3. 3 times minus cos squared x is minus 3 cos squared x. So that's why I'm saying this is a monomial by a binomial. Okay. Plus 10 cos x, there it is. Minus 6, there it is. Equal to 0, there it is. Then minus 3 cos squared x. Okay. Because I want standard form again. Minus 3 cos squared x plus 10 cos x, and then 3 minus 6 is equal to negative 3. So this is plus 10 cos x minus 3 equal to what? 0. Okay. Then look at this. I multiply both sides by a negative, because, or divide by a negative, because I can see this is a negative 3 cos squared x. So when I divide by negative, this becomes positive, this becomes negative, this becomes positive, and it's equal to 0. This is now is officially a trinomial. This is a cos squared x term, this is a cos x term, and that is a constant term. I can factorize this. How? Obviously, I can factorize it. Now, I said those who can't factorize an advanced trinomial, because remember in grade 10, you guys learned how to factorize trinomials where the coefficient is greater than 1. Okay, there's the trial and error method, and there's also the method whereby you can group. So I use the trial and error method because it basically appeals to me. But those who may feel like they don't know how to use that method of solving for the value of cos can go ahead and basically use the quadratic formula. You just let cos x be x so that you can find the x value, and then don't forget after you find the x value to substitute. Because remember, you wanted to find, but maybe just to avoid confusion, guys, I'm thinking that many people might make the mistake because I said cos x. Now all of a sudden you get x, now you substitute the 3 in the place of this x2, and that's not the point. The point is to try and get this value of x. So maybe you might want to consider a different variable than what? Than x. Maybe you can say let cos x be equal to y, or maybe you can say let cos x be equal to k, or any other variable. Okay, yeah, just long as you remember that what you are trying to find is this value. Okay, yeah, maybe you can say let it be k, let cos x be equal to k, but remember then you're going to have to find k first, and after you find k, you take the k, you substitute it back in the place of k. Does that make sense, guys? Yeah. So you do that, you find that particular k, y, or p value, whatever letter you want to use in this place. Okay, yeah. I'm just gonna put a little bit of a circle there because I am meaning, obviously, that's what I want. I want these. So please, guys, you try and use another variable, because I'm just thinking it might lead to a lot of confusion and people might make mistakes. So try and find another variable, maybe k, okay, or something else. Once you find those two values, you take them, you substitute them back, because remember, you were letting this be equal to that so that you could find this and then substitute back where that is. Okay. Then after you are done with that, I said cos x is equal to 3. There's no answer there. Not applicable. The reason is, if you take, because remember, you are going to say x is equal to cos inverse of 3. You can go to your calculator and say shift cos of 3. You close, you can see it says maths error. That's why I'm saying there's no solution here. Okay. But then cos x is equal to 1 over 3. There's definitely some movement you can get there. Cos x is equal to 1 over 3. You can see. So then you write down your reference angle. You guys say it's your RA. I like that. I mean, we can write RA instead of ref angle. Okay. Yeah. Remember, RA, reference angle, one and the same thing, but you can say RA instead of reference angle is equal to the inverse of cos 1 over 3. You punch that into your calculator. Someone said they got a different answer. So let me check quickly. Cos fraction 1 over 3, 70,528. Yeah, that is 70,528. Okay. Baby girl, that's fine. We can write RA. That's fine. Okay, I'm guessing a lot of people are using Kevin Smith. Yes, there's RA. Okay. And then we round off this into 2 decimal places. Our final answer needs to always be rounded off, okay, to 2 decimal places. So I tend to write out the entire value until the very end. Then at the very end, I will round off to 2 decimal places. And like I said, you can say 360k or you can say k360, guys. It doesn't really matter because multiplication is commutative, though. Whether you say k360 or 360k, it's of no real significance. It's just a reminder that whatever you are going to be substituting here, you'll be substituting a particular integer, which you will then check whenever you want to find specific values in a particular interval. Okay. Then fourth quadrant. What's k? K is an integer. K is any integer value. So in other words, you could substitute 1 here. Remember, integers are what? Integers are positive and negative whole numbers. Like 0 is an integer. So if you substitute 0, for instance, 0 times 360, that means one of your x values that actually is a specific solution for this equation is actually 70,53 degrees. If you substitute 0, you get 70,53 degrees. If you substitute 1 times 360 gives you 360. 360 plus 70,53, that means you get a specific value that is outside the 0 to 360 interval. It is in the it is in the 360 to 720 interval, and that particular value is 400 and something. Yeah. So when you substitute integers, you get specific values of x that actually satisfy this equation. What this is a general solution. It is not a specific solution. It is a general one. Through the general solution, we can find specific solutions. Okay? Yeah. General mostly, it's like me saying all girls love boys. That's a general statement. But if I go to individual people, I'll have to basically ask. You will find that not all girls actually love boys. Okay, so general solution is general, but solutions that are specific, they are to the point. They have reference to a specific thing. So if I'm saying now I want a specific solution between the 720 and the 800 interval, 720 and 800 degree interval, I'm going to substitute maybe 2 so that I can find that specific value. Okay, because 2 times 360 will give me 720. 720 plus 70.53 will give me a value that is greater than 720. Does that make sense? So basically, that's why we have this K360. Okay, yeah. So for the first quadrant, okay, this is something I want to just state. Remember, that's in the first quadrant. So for 0 all the way, 0, 90, 180, 270, 360, there's that solution in the first quadrant, which is 70.53 in the first revolution. But what if we continue in the second revolution? In the second revolution, 370 plus 70.53, there's another value that is greater than 360 that is still is in this quadrant. If we go to the third revolution, there's another value, 720 plus 70.53. That value is also in another revolution. If we continue on and on and on, there are more values that are greater and greater that are situated in this particular quadrant. Okay, so that's basically that's the whole meaning behind why there's a K360 there. This helps us to be able to locate more and more values of x that are in other intervals that are even way greater than 360, way greater than 720, way greater than 1080, way greater and greater and greater in other revolutions if we go on and on and on in the positive direction. Okay, then there's another answer that is in the fourth quadrant. Okay, no, look, remember x is a variable, and since x is a variable, my man, x is a variable that is very, very famous, asking does x ever leave maths is like asking a person who has been in a relationship with someone, will that person ever leave their heart or mind? And I can tell you this one thing, that person will never leave that person's heart or mind once they become their ex. That person will forever be remembered, even for future times to come, So does x ever leave maths? That's like asking, does an ex ever leave your mind and your heart once that relationship is finished and gone? And the answer is no. That's fine. If it's a bad scenario, Liabona, I can rest assured that bad scenario will probably never leave your mind, ever. Guys, I'm gonna have to love and leave you. This is basically where I'm cutting it. But thank you so much for joining in. You guys were very pleasant. You were good sports. We'll definitely be seeing each other again. Yes, Mrs. M, I've done cast diagram. So what I will do is I'll actually download the video. I will post it up onto the YouTube channel. Please, guys, the YouTube channel, Maths is a Game as well. Everything is Maths is a Game, guys. It's dark because I've made it dark, Doho, because I'm done, I'm finished, it's over. That's like, will X ever live? Yes. And will an X ever live? Yes. And does it become dark thereafter? Yes, it does. So guys, this is just also a symbolism that it's now time to sleep. So it has to be dark before people sleep. It's very key. Mrs. M, what do you want me to answer? You're saying, please answer me. I answered you. You asked, have I done cast diagram? And I said yes. What other answers do you want, Mrs. M? Because now I have to sleep and I have to go and visit those who require me in sleeping aid. Luke 137, with men it shall be impossible, but with God nothing shall be impossible. What's your problem, my friend? Okay, thanks, sir. You are teaching me. Yes, Toho. You are welcome that I taught you. Everyone who was here, guys, all of you that have hanged on tight for the longest time, Toho, Sihle, Chloe, Contagious, Michael, do what you want to do. Mrs. M. Katleko, dear Novenus. Hey, Gohula, Quinika, it's Puti, Zian, Hotazo, BB, Chiskop, Khalimo, M2C, Eniola, Cholani, Jude, Lester Lee, Tabu, Sanobia, Makabaza, Ambani, Muano, Itumeleng, that guy Bongs, Noltando Zulu, Esbambo, Skuha, Skurati, Skutababa, Genaba, N, Spongomane, Lira, Pru, Maburna, Legend, Pyromaniac, Hehe, Mahlob, Camlin Naidu, Yena Yedwa, High Boy, Klesiva, Phil Touch Fashion, Jaja V, Yamkela, Nis, Hey, Yamkela, Matlo, Mabongza, Zimbuduma, and everyone. It's fine. It was good, guys. You can say Allah Lenina. Danko, Liabona, I really appreciate that. Forgives and now say I want to sleep too. Definitely, I'll be energized and rejuvenated and revitalized in the morning. So those will be joining in the morning. I'll see you guys then. I can hear by your tone you really need a nap now. Thank you so much, Sbani. Definitely. I need to turn the lights out. I need to turn the Sbani off and turn the good night sleeping on. Yeah, guys, thank you. Have a good one. Lots of love to you guys. Like, yeah, man. I never knew I would learn to love strangers the way that I do. The time that I come on, sacrifice, have good times, teach the maths, explain critical concepts. I only hope that it will have efficacy for you guys and that it will transform everything. Have a good one. With men, it may be impossible, but with God, nothing shall be impossible. Luke 1:37. Cheers. Cheers. Bye bye. Litlaubona kausane. Yeah. It's to